Hi everybody, this is Mr. Brooks, and this is the third video on polynomials. Today we're going to be talking about the zero product rule. And first we talked about addition, subtraction, and multiplication. We skipped over division. We're going to do that in Algebra 2. And so the zero product rule is something that is actually very simple and very easy, but because of the notation and because of the way it's written and the language it's in, and we haven't seen it a lot, it can be very tricky to understand exactly like how to write it and how to do it and commit it to memory. This is one of those where you need to commit it to memory and practice it every night. And then once you get it, you'll take it with you forever. And it'll be the easiest thing you can ever do on a test. The learning target is I can find the roots or solutions from the factored form using the zero product rule. And then I can find the y-intercept. And the top one is absolutely a must essential. You must do that, and you must do it well in order to feel comfortable in algebra for Algebra 1 and for Algebra 2, as well as some concepts in geometry. And the other one, the find the y-intercept, is an extra thing for understanding and comprehension. It's good to know. The vocab for this is root, solution, zeros, x-intercepts. You'll see those are all together, and that is because those all mean the same thing. So we're going to use a lot of different words, and they all mean exactly the same thing. And hopefully we all know an x-intercept is where the graph touches the x-axis as measured, by the number line. Those are also called zeros. Those are also called solutions. So if you see x equals 5, the x-intercept is 5, or the 0 is 5. And the root is just another word for a solution. Okay, and then factored form, I'm going to go over that. But you got to know the difference between factored form, standard form, and the roots. Okay, so here is factored form, all right? And this is factor 1, and this is factor 2. Two binomials. And remember that factors are just things that are multiplied. So we're multiplying k minus 2 times k minus 3, and we covered that under FOIL. And factored form would technically be equal to y. So these two numbers multiplied together is equal to the output. K would be the input, or sometimes you'll see x here, like x plus 1, x minus 5. It doesn't matter. But notice it is a variable, and then plus or minus a constant, variable plus or minus constant. Each of these are factors, and that's set to y. So you have x and y. Whereas before we had linear, y equals mx plus b. That's slope-intercept form. And now we have factored form. Okay? And right here, this is our example of a polynomial, and this is standard form. This is also equal to y, where you have x squared plus 10x plus 25. And notice it's in standard form where the 2 and then x to the 1, and then this would be like x to the 0. Okay, so it's all in order. Okay, so hopefully we understand factored form and standard form. And let's talk a little bit more. Okay, the intercepts. You notice that if you remember your parent functions, you'll know that a quadratic, it takes the shape of a parabola, which is a u. So this is our parabola right here. So these go on forever and ever. And we have a minimum right here, and we go on to infinity, negative infinity. And if you look at, so every time you see right here, this is x and x, so it's x squared, which is a quadratic, which is a u. Okay, and you can make the u big or tall, or you can face it downwards. But if you think about graphing a u, you are always going to have one y-intercept. You'll never have two y-intercepts. Okay, and you can have two x-intercepts, or you should have two solutions. Okay, it's going to get a little bit more complicated, but for now, you need to know that you should have one y-intercept always, and you should have two solutions or roots to your factored form or your standard form in a quadratic. Okay? To find the y-intercept, you're going to set x to 0 and solve for y, because right here, for example, okay, the y-intercept right here, x is equal to 0. So if x were equal to 0, then you know what y is. And then for the x-intercepts, you set y to 0. So right here, on these two, the y is equal to 0. And then you just plug that in your equation and you solve it. Okay, so let's try a few. Alright, so here we have a couple binomials. Remember that this is equal to y. And the first thing I'm going to do is I am going to solve for the y-intercept. And we're going to put the x to 0. Okay, so we're going to plug in 3 times 0 plus 3. And we're going to multiply that by 0 plus 4. And that is equal to the y-intercept. So 3 times 0 is 0, plus 3 is 3. And 0 plus 4 is 4. And so the y-intercept is equal to 12. Okay, and you can probably do that in your head after you've done a couple. Okay, but the more important thing is, what are the x-intercepts, or what are the solutions? And for that, you're going to set y to 0. Okay, now, if y were equal to 0, then what number times a number is equal to 0? Think about that. What number times any number is equal to 0? Well, that's 0, right? The zero product rule. So 0 times any number is 0, and any number times 0 is 0. So we're going to set each one of these factors to 0. So we're going to have 3x plus 3 equals 0. And then we're going to solve for x. Minus 3. I'm going to keep it there. I should have just kept, I was trying to be fancy with it. I'm going to take my time. So 3 times x equals -3. And divide by 3. And x is equal to -1. Okay? Then the other one, set the other one to 0. So x plus 4 equals 0. That's the second factor equal to 0. Minus 4 both sides. And you've got x equals -4. So how many roots do you have? You have 2. How many solutions do you have? You have 2. How many x-intercepts do you have? You have 2. And how many zeros do you have? 2. And those are all the same. Okay? All right, the next one right here. To find the y, you set x's to 0. So it would be 0 minus 2 times 0 minus 3. And that tells you the y-intercept. And that would be -2 times -3. And that would be +6. Obviously, I don't need to write the plus there, but I got a little ahead of myself. So the y-intercept is 6. Okay. And then for the x-intercepts, we're going to set each of the factors to 0, which is the same thing as setting y to 0. So it's going to be k minus 2 equals 0. And k minus 3 equals 0. So k is equal to positive 2, and k is equal to positive 3. Okay, can we see a pattern? So right here it was x plus 4, and it's negative 4. Over here it's k minus 2, and it's positive 2, k minus 3, positive 3. If you notice, it really is just change the sign, okay? And I'll talk about that more later. And the same thing happened here. It would just be a little bit complicated because they put 3x plus 3. But you'll see how it kind of takes one more step right here. So the last one, notice it's not x by itself, but what we would do to, well, let's solve for y first. Just set x to 0, so it would be 3 times 0 plus 4, and then we are going to square it. And then that would be 4, because 3 times 0 is 0, squared is 16. So the y-intercept is 16. Okay, and then the x, remember this is repeated twice, so actually we're going to have the same exact we're going to have the same exact x-intercept for both factors because it's the same factor, so we only have to do this once. We're going to set 3x plus 4 equal to 0. And we solve. And you'll notice it's going to fit the same pattern. You just it's a little harder to see because of the extra step. All right, so minus 4. And that cancels. And we have 3x is equal to negative 4. And divide by 3. And that is going to be your x-intercept, or your solution. Negative 4 over 3. You can also write that as negative 1 1/3. It's the same thing. It doesn't matter. Okay? All right, let me show you this kind of pattern one more time. Okay, let's say, for example, that you had a factor of like x minus 7 and x plus 9. What would your solutions be? It would be the opposite. So it would be x equals positive 7 and x equals negative 9. So it's just the opposite. Let's do one more. Let's see how easy this is, how nice this is. What if you had x minus 2 and x plus 22? Okay, and we don't even have to write equals y, but it's always assumed equals to y. And the answers are x equals positive 2, opposite, and x equals negative 22. Okay? And one more thing you might see, maybe you have two factors, maybe it's like 3x times x minus 100. Okay? Doesn't matter. So maybe you think this one is easy, where you say x is equal to positive 100, because it's just the opposite. Well, what about this x over here with the 3x? You know, that's a factor. If you set any number x, or 3x, or 5x, or negative 20x, if you set anything without a plus or minus to 0, then of course it's going to be 0 because you're just multiplying by 0. Okay? All right. Hopefully that makes sense to you guys. Please commit that to memory, especially the zero product rule, and hopefully you find it a little bit easy where you see the pattern. Sometimes if there's a coefficient in front, you do have to set equals to 0 and solve. And there are going to be a lot of practice problems, but you guys can do it. I believe in you.